Back on the whiteboard for the final phase of our caterpillar project. We've done a lot of modeling and animation, and today we're going to kick it back over to the animation side for our final sort of phase of this. And we'll split this into two different sessions. There's a lot of stuff that we need to animate here, and I think trying to do it all in one lesson might be kind of insane. So I think 2 lessons is a good number to get the things done that we need to. Now, we will still follow like a logical progression of kind of like what logically follows to work on next. But since we are splitting this up, we can focus on a different concept in each lesson. So for today's session, let's talk about keeping our animation grounded. So what does that mean? Well, in the past couple of lessons, we've been modeling out the various appendages of the caterpillar. And in today's lesson, specifically, we're going to be animating the legs, which is the part of the caterpillar that touches the ground. And so that's kind of the more literal meaning when I say that. The second meaning is a little bit more sort of high concept. Maybe it's a bit of a stretch, but the basic idea is we want this to be grounded in reality as well. And now it's not the real life reality like we'll see in the reference video that I'll link to in the description again. Which you should definitely check out if you have not seen that yet. So it's not going to be a realistic animation. It will still be highly stylized, but there's going to be a reality of this animation. And we want to make sure that every movement that we add to this is sort of motivated by some specific reason why it's moving. If you combine that idea of groundedness with the literal meaning of what we're going to be doing, which is making these legs make contact with the ground, they can't just be touching the ground. They've got to be doing specific things when they touch the ground in order for it to make sense. So let's go through and list all of the different elements that we'll be animating here. We've got our front legs, and then we've got the hind legs, which are technically not legs. I think they're called pro-legs, technically. And these are the only 2 groups that we'll be actually animating in today's lesson, but we will get to, in the next lesson, also these horns. And I'm not really sure what those are called technically. Maybe antenna, not sure. And we may get to some other stuff too. But the basic idea is, and why I was sort of writing these down, is that if you recall what we did in the previous lesson, we assigned these to the UV1 channel as far as the parametric coordinates that tell us where we are along the limb. The V coordinate, that's really the parametric coordinate we really care about, is this lengthwise parameter that sort of is telling us where on this path we are, because that's what we really use in our animation. So, right, for the body, which is in UV0, right, that's 0 up at the front, and then it goes to 1 at the back of the body. Now for the UV1 layer, that's going to be 0 where this limb attaches to the body, and then at the tip of the limb, it will be 1 for all these different limbs. But you can see, right, these are all sharing the same layer. So how are we going to tell the difference between the front legs and the hind legs, or even the horns when we start animating those? The way we can do that, and this is something that we did at the end of that last lesson there, is we can use our UV2 channel, which is where we have some IDs. So we put a group ID. This is, I think, what we'll really use in this lesson. And then we also have an instance ID, and we put these into basically this unused UV2 channel. So this is how we'll tell these groups apart in the Vertex shader, is that we need to look at our UV2 channel, and then we need to look at our UV1 to actually add animation to these elements. And so let's get started by just making sure that our shader has access to these attributes. Let's come into our PFX lit surface shader. This is our sort of Uber shader. And let's scroll up to where we have our Vertex attributes. You can see we just have a single UV layer, which is a layer 0. So let's add our UV 1 and 2, and we can make sure that those have the text chord 1 and 2 semantic. That will make sure the renderer is passing the correct data to this. And so let's test these attributes out now. We want to make sure that they're coming through, and we also want to make sure that we know kind of what group ID belongs to what group. And to do that, let's start giving the caterpillar some colors. So let's also add a vertex color here. Now we don't have any color data coming from the actual mesh, but we can sort of fill this in as part of the shader. Okay, so before we leave this Uber shader, let's scroll down here, and where we just apply our base material color, let's also come in here and multiply our vertex color in, which should default to white, so it will make no difference if we don't have any data there, but then we'll fill in some data in our shader. So let's make sure this compiles. looks as expected. So now let's get started by adding in some color data. And let's just add like a comment to say we're adding color here. I think if we don't start doing this, this will get unwieldy pretty fast. So let's say we're going to add color here, and let's just see if that vertex color that we added is going to work. So we can say a body color, and I want this to be like a pale green. So there can be some red in this, and then we'll have fully saturated green, and then we'll put like a little bit more blue in than red to make it slightly like a blue-green, and then we'll have 1 as the alpha. And so we can just do something like this to assign our body color back to the vertex color that way. Because you can see this vertex attributes in is being passed with an in-out qualifier here. Okay, so if you have questions about that, you can check out the Uber Shader lesson where we set this whole thing up. But let's just see if this works. Okay, so our color is working. So now what I want to do is let's test out our UV1 to make sure that that's coming through correctly. And I think what we can do is let's give the ends of these legs, like we can call it like the foot, even though there's not really a foot there, but let's just call it the foot. Let's make those like a pale yellow. Okay, so we'll interpolate from green to yellow on the legs. And remember, the body doesn't really have any data in that layer 1. It just has 0 filled throughout it. So that should stay green, while the limbs or the legs should sort of interpolate from green to yellow. So we can say our foot color is going to be, let's say, 1-1. We keep the blue channel the same, so it will be like a pale yellow. And then we can just try this. We can say body color, and then interpolate to the foot color by our UV1.y. And let's just see if this is coming through correctly. All right, so that is looking like what I want to see on the legs. Now the problem is, right, as we just mentioned, we're not differentiating between the various different groups. So anything that's on layer 1 is getting this same coloration. So the spots are getting it, the horns are getting it. So now let's set up our groups, which is going to be on the UV2 layer. So I can just make another little section for this. And the first thing we can do is we can get our group ID by looking at our in.uv2.x, because we put that in the first component of this, and the instance ID is on y for this. Okay, now we need to know which group ID corresponds to which group. And so I'm wondering whether or not we can just look at the order in which we added these groups. Here we've got base mesh first, then hind legs, front legs. So I'm wondering, is the base mesh group 0, and then hind legs would be group 1, front legs would be group 2. So let's try that. We can say is hind legs will be if our group ID is equal 1, and then our is front legs will be group ID equals 2, and then we can say if it's a leg at all, and maybe we'll just get rid of this S so it's a consistent naming, is leg will be if we're the hind leg or the front leg, then we're generally speaking a leg. And then what we can do here is we can make this the leg color, and then what we assign to the actual vertex color can be conditional on if we're a leg, then we'll use the leg color, and otherwise we'll use not the body color. It will be the body color in this case, but let's try this, which would be basically just keep whatever's in there currently. Okay, and so that worked. And we can also just verify that we don't have these hind leg and front leg groups mixed up. We could say, okay, only apply this color to the front leg, and we can see, yep, it's only applying to the front leg. So I'm pretty sure that these group IDs will just be the order we see here, which is actually kind of convenient. So just walking down through these groups, the next thing that comes up is the spots. And for the spots, we don't really care. We're not going to do anything differently with the left spot versus the right spot. So we can just say is spot generally. And that will be if our group ID is equal to 3 or if it's equal to 4. And I think for the spot color, we want to use the body color, but then we want to like darken it. So we can say like 25% darkness on the spot. And then we can say if we're a spot, we'll use the spot color. Otherwise, just keep what we've got here. So that's either going to be the body color or the leg color at this point. Right? Okay, so now we've got our spots. We can check the other side, and that's working on the other side of the body too. All right, and now the final groups are the horns. So we've got our front horns and back horns, and we are going to want to do something differently here. So we'll say is front horn is first, and that's going to be if group ID is equal to 5, and then we'll get our back horn for 6. Then we can see whether or not this is a horn at all. Okay. All right, so now for the horns, we're going to want to have something a little bit different happening here. We want the front horns to be red and the back horns to be yellow. This is sort of roughly based on our reference, though the reference does not have this number of horns. It's a slightly stylized, fanciful version of the reference, but I like the way that they're colored in the reference. So we'll say the front ones are going to be this bright red, and it's just at the top of the horn where we see these bright colors, but let's look at that color first. So we'll say our horn top color, and this is float 4. This will be, if we're the front horn, it'll be red, and then the back horn will be yellow. Okay, so that would be the way to do that. And so then we can say is horn, we'll use the horn top color for now, and then otherwise keep the existing color. All right, let's just change this yellow slightly. I think it needs to be a little bit less green in here, a little bit more sort of a golden. I think that's better. All right, so now let's get a base color for the horn. So what's going to happen here is you're going to start out actually at the body color for the very wide part of this, and then it will switch to be more of a black color, kind of like the spots, and then it will switch to being this horn top color finally. So let's create our horn base color now, and we'll say this is conditional on whether our UV1 .y is less than 0.25, let's say. So if we're less than a quarter of the way up the horn, we'll use the body color, and otherwise we can use the spot color for the base color. And so then we've got our top color already. Now we can say, we can combine these and we can say the horn color, and we can do the same structure as this conditional statement, but we can just move this further up the horn. So we can say if it's less than 0.5, less than 50% of the way up the horn, we want to use the horn base color. Otherwise, we want to use the horn top color. Okay, and let's see what that looks like. We got to put the horn color here rather than the horn top color. And so I think we've got some good colors for our caterpillar. I think it already looks better than just being that pure white. And the other good thing we've done here is that we've set up our group IDs that we can use to actually start animating the legs now. Let's now add the fact that these limbs should be touching the ground, like the feet, we can call them. Let's do the grounding here. And I want to do this at the end of this animation shader because we may be adding all kinds of different offsets to the vertex first, and then we can just make sure as a final step that the grounding is working correctly. So we can create something called like stick to ground T. And again, T is just kind of what I use to signify that this is like a parameter that ranges from 0 to 1 or like 0% to 100%. So how much is this particular vertex sticking to the ground would be this value here. Here we could say, we could almost do the same type of logic as we did to make the foot turn yellow. We can say basically as it turns yellow, we want it to be sticking to the ground. For that, we took our UV1.y, and then here we can just multiply in is leg. And so this is kind of a fun feature of HLSL, is that we can take a Boolean and use it like it's kind of a mask, a 0 or 1 mask. If you just multiply it into a float value, it will just automatically do that casting, which is kind of nice. Okay, so that will tell us whether we want to stick to the ground or not. Okay, and then from there we can just do something really easy. We can take our world space position.y and interpolate it from where it is currently to the ground plane by this stick to ground T. Okay, so let's see what that looks like. And so, okay, that looks goofy, but it is doing what we want it to do, right? If we look at this sort of from this angle, you can see, right, these are all kind of sticking to the ground plane, right? And then if we look at it from like a side view, we can see there's a straight line here that these are now sticking to the ground. Now, obviously, when these come off the ground, it looks totally wrong, okay? But if we turn this off, right, you can see this is not a straight line at all, because as the body gets narrower here, it's kind of lifting off the ground. And so I think this is the beginnings of something that's going to look good. And so now we can just kind of proceed logically from here and say, well, at this point, we just need to make sure this doesn't stick to the ground when the segment kind of pops off the ground like that. So if we look at where our segment's animating in our segment animation section here, here's where we apply that offset in Y. And this jump T is that 0 to 1 value that's telling us sort of how much of this vertical offset do we want to apply, sort of from 0 to 100%. So we can basically just say our stick to ground, we can multiply in not our jump T, but 1 minus that. So we can basically say if we're jumping, we don't want to stick to the ground. And if we're not jumping, we do. Okay, so that's already looking pretty reasonable. And now the thing that I want to change at this point that's most obvious to me is as this is lifting off at the back here, this hind leg at the very back is getting really long. And this one seems to look like it's kind of getting long too, because right, it has to move a longer distance to get to that ground plane. So we can just kind of cheat this in the Vertex shader. We don't have to change the length of the model as we distribute it back and do something fancy like that. We can just say, we can just create like a droop here, and we can call it droop T. We can use the bodies, so not UV1, but just the body UV. And we can kind of ease this in. So most of the time there will be no droop, right? It will stick to the 0 bound, but then at the very end, it will droop down. And then we can say like wspause.y minus equals droop T times, let's say 0.5. So, all right, now I think we moved it too much. So let's kind of reduce that. We could say maybe 375. Okay, I think that's pretty good. Now I think these segments back here are moving down a little bit too much. I really only want it to kick in at the very end here. So we can change this ease in, make it even more dramatic here. And that's pretty good. Maybe we can just go even lower on this offset amount. No, I think 375 was good. So now at this point, if we look at what this looked like without the grounding, we can see, right, I think it's definitely looking more like an actual crawl at this point with that grounding that we added. But we can go a lot further with this. Look at these front legs, and we'll start adding some specific animation to the front legs now, right? There's a ton of sliding going on here. So this is kind of what I meant by it's not enough for it to touch the ground. It has to be grounded in sort of conceptually as far as what should happen when it's touching the ground, right? It shouldn't be sliding around like this. It's touching the ground because it's anchored to the ground. I think this may be a good time to kind of just step back and review a little bit what's going on with the animation that we did in our first pass of the animation, because it's going to factor in heavily to how we want to fix this sliding issue. So if you come up to our overall cycle here, and I think maybe we should rename this move progress T, because this is not what's actually creating this body move here. This here, overall forward move T, is what's doing that. So this is probably a better name for this, might be like cycle progress T. This is kind of just the overall animations progress for the entire caterpillar. And then this thing specifically is controlling the body's sort of root level motion. So we can call this like body move T maybe. And we can replace that everywhere. And let's just make sure that those compile. Okay, so basically what's happening is that we're moving the entire body with this line of code here. And what we wanted to accomplish in that first pass of the animation was we wanted to create this cascading motion where these back segments are moving forward, they're kind of leaping forward, and that would make it look like it's pushing the whole body forward. So I think we accomplished that. Now, if you look at what's happening in the front here, the body is starting to move before this cascade of the segments actually arrives up here. And so the slide is happening basically before this lifts off, because the body has already started to move before the jump T kicks in, and the jump T is being driven by the segments animation. So let's come over to the whiteboard and see if we can visualize what it currently looks like and then what it should look like. Let's just take like a single leg and let's visualize what happens to that single leg as the body's moving. So we're basically just seeing that leg being dragged by that body motion, just sort of following it 100% along the entire length of the leg. And then at some point it lifts off, and so I'll put the second half of this in different colors here. This is after that jump occurs, and it's still kind of following the body the same exact way, but we're seeing most of the slide here because this segment animation doesn't play until a lot of that body move's already completed. But what we want to see here with this leg is that as the body's moving, we want to see it sort of jump from one foothold to the next, and we kind of don't want to see it touch the ground at all unless it's touching one of these two footholds. So this would be like if we apply no offset, and this is like if we apply the full move distance that the body will have moved over the course of that whole cycle. So the beginning and end of this is going to look the same as what we currently have, right? Where we're fully just sort of aligned over our start foothold or our end foothold. But in between, it's going to look kind of more like this, right? Where the top of the leg is going to be following the body, but the bottom of the leg or the foot should be anchored to this foothold. Okay, and then the same thing should happen after this jump occurs. It should jump to the next foothold. It should not slide at the end of this either. So let's work on our front leg animation here. First, let's just figure out whether or not my diagnosis is correct. So we can try subtracting off this overall body movement that's occurring. So that's going to be our body move T, which is like the percentage of the move that we've applied so far, times the move distance, which we will travel for the whole cycle as this value goes from 0 to 100%. So this is the overall offset that's been applied to the body. So if we subtract that out from our world space Z, if we are a front leg and we're sort of at the bottom of our UV1, and actually maybe we could say front foot mask is going to be this value, and then we can multiply that in here. Okay, so let's just see if this kind of fixes the problem. And so now obviously we can see there's a problem at the end there, but before that little hop, I think it actually looks pretty good because it's doing what it's supposed to do. It's staying on that previous foothold. Now when that hop happens, it should move to the next foothold. It shouldn't stay on that previous foothold. Then it starts looking broken. But this is a good start here. So now when the hop happens, that hop is being driven by the segment animation. So we could take our segment progress and say we could sort of cancel this as the segment progresses from 0 to 100%, right? This value will go to 0. And let's see what that looks like. Okay, so that's pretty good. Now, the only thing we didn't fix here is we didn't have that actually move to the next foothold. So if you'll notice, there is a slight slide there. Now, it's not nearly as egregious as the first half of the slide, but let's try to fix that too. And the reason that's happening is that the segment animation is completing. Let's say for this one, we're going to have more of a slide on this leg, I bet, in the back here than we do on the front, because the front leg segment animation probably is finishing much closer to when the body animation finishes. The body animation is going to finish at the very end of this cycle, whereas the segment is allowed to finish before that. And when the segment animation completes, the foot will be touching the ground. So before that can happen, right, we want this foot to already be on its next foothold. What's actually happening currently is it's only reaching the next foothold when the body animation completes. So basically, if the segment finishes the animation before the body finishes its animation, we'll see a slide here. So to fix that, we can just get like we can say seg end diff from body end, right? So we can just say segment progress T minus our body move T. And so let's say, right, if the segment is 100% the way through its animation, but the body is only like 90% of the way through, this will be 10%. Okay, and we have to make sure that this is not allowed to go negative because the body will start before the segment starts. So we don't want that to go negative. And we can just say, okay, let's say this is like that 10%, right? The body's only 90% of the way through, but the segment's 100% of the way through. We want to then move by 10% of our move distance, move this leg forward by 10%, or whatever this value is here, of our overall move distance, and then we can multiply in our front foot mask, and let's see if that fixes the issue. So that doesn't fix the issue because we need to add this. We need to go forward in Z, and right now we're sort of making the problem even worse. And so then you can see, right, that the foot now is hitting that target, and then the base of the leg now is still doing the slide, and it kind of catches up to the front of the foot, which is now leading. Okay, so if we zoom out here, we can see what this looks like. And then just for good measure, we can take a look at it, what it looks like without that, right? That initial slide's really bad. So we can now look at the end result, which is much better now. Okay, so now I think we've finished with the front leg. I don't want to do anything too fancy with this. So now let's take a look at the back legs. And you can see there's like a slide happening here too. It's kind of happening in the second half of the animation. And this might be a little bit weird. It was weird for me at first seeing that because this is something that we tried to address when we did our first pass of the animation. And we didn't use the term foothold, but we were looking at the same idea, which was as the segment moves through its sort of animation, it should move by that full move distance to the next foothold, and then that would create the idea that it's propelling the whole body forward to its next foothold. And then as the body does that, we'd sort of cancel out this segment-specific move here, and it should all kind of come out in the wash and be fine with no slides, right? Well, the problem is that we're adding this back influence thing here, right? And actually, if you see, there's no slide on this most hind segment, maybe a tiny little bit, but it's pretty much not sliding in the back, and this one slides the most in the front. So as we go to the front here, we're not actually moving the full move distance. We're blending that out. And so that's what's causing this slide. If we just remove this back influence T here, I think we should no longer see a slide. Let's see. Right, so we're not seeing these limbs slide anymore, but we're not really getting the animation we want, right? We want this to blend out, and we want to see a different style of motion in the back versus the front here. So we want to keep the way that the segments look, but we want to fix this sliding of the feet. Now that we have the feet here, it's kind of distracting. So to fix this, we can just do something similar to what we just did with the front legs, where the part that attaches to the body can remain that sliding behavior that we like, but the foot part should just stick to that next foothold, right? In this case, we're more concerned with the next foothold than we are the previous foothold. Okay, so we can create like a back leg animation section here, and we can just say the sort of issue that's being caused here is this back influence T. And this is basically telling us how far on the back are we? Are we 100% in the back where this motor is running kind of, right? Or are we 80%? So if we're 80%, we need to move the foot by 20% forward of this move distance. If we're 50% back influence and we're only moving the segment by 50% of this move distance, we need the foot to compensate for the other 50%. Okay, so we can say here, WS pause. Well, first we'll create a back foot mask, and so this will be similar to this, but we'll just use the back leg. Or did we call this the hind leg? We call this hind leg. So we can call this hind foot mask. And then here let's now add to our world space position Z, our hind foot mask times our move distance times 1 minus back influence T. Right? So if this value here is 80%, then this should move us 20% of that move distance. And let's see what that does. Okay, so this is not quite right because, right, we're sort of applying that offset twice now. So we need to make sure that we're canceling this out as the body moves forward. And let's see what that looks like. Okay, so this is now looking right at the end of the animation. But if we come back to this diagram, right, at the beginning, we can't have an offset either. And so before the segment moves, there's kind of no problem that we need to fix. The problem only comes into play when the segment moves, and let's say it only moves 80% of the way to where it should move. And so what we can do here is we can then multiply in our segment progress T, so that if this is 0, right, we won't apply any correction. We'll only apply the correction as this reaches the end of the segment move. And that's pretty good. I think we can maybe add some easing now to this. So we can say like ease in out on this maybe, so that we see these kind of kick forward a little bit sort of midway through the animation, like something like that maybe. That may be a little bit too much. I think 2 is pretty good. But so I think we've kind of fixed this grounding issue for our legs. This is looking much more sort of realistic, like a crawl, right? Now that the legs are actually animating and they're grounding themselves properly. So at this point, we've got a pretty nice functional crawl. And I think in the next lesson, let's now start adding a lot of polish to this and really take it to the next level with some embellishment.